In this session, we shall go with rigorous distillation, or we can just call it as a rating of a distillation column. We take what we call the output from the shortcut distillation, what we have obtained, and use that to build a distillation column. So output from shortcut distillation column, and we will be simulating the distillation column, and you find it here at the bottom. That means under the columns you find this particular column, distillation column. You can take this here. Sensitivity study can be carried out with this particular unit module, not with the shortcut distillation column. This is again one more feature we need to understand. Again, what are the inputs we need for this particular distillation column and all? We have to specify in the distillation column. That is what we need to understand. So feed and what do you call flow rate, composition, of the more volatile component, its condition is required to specify, and then column specifications are again the input. We can say column spec is again the input. So I can say condenser is total, and reflux ratio will specify reboiler. That means at the bottom what needs to be done, and then we want what you call light key and heavy key. We need to specify at the top and the bottom, or light key in the bottom and heavy key in the top. And of course, is there any pressure drop? So these are the specifications. That means this one and this one are supposed to be the inputs to the total entire simulation system. Okay. So how much is what are the values, how much, or you can say, what are the values and all? I will give the input here. I will show the input to you, and then we can understand. Okay, let me check out all these here. Done. Okay. Now, let me go to the simulation. Now, in this simulation, this is a shortcut distillation column. So I delete this. Very simple. Our inputs, outputs are there here. I take this distillation column here and then drag and then come here and place it here. Automatically, the what you call the streams gets connected. Of course, the rearrangement of the streams so that it looks nice. That arrangement and all, I don't have to. I'll just carry out here. I don't have to tell you how to do it, right? So this extra streams, energy streams which are there, I will remove them. Yeah, deleted. And this stream, energy stream, rotate. Yeah, by seeing the what you call flow sheet window, you will be in a position to understand what to do. So these are the arrangements which are done. Now this is a rigorous distillation column. For ease of understanding, let me show you with a bigger picture. So how it is being shown. See, now this is the bigger picture. Input, it looks, there is a ladder, there are number of trays. Yeah, reboiler, you see, horizontal kettle type boiler, condenser is a vertical condenser, no issue. There is a vent also. Okay. So this is a typical layout as if we see in the industry. Okay. Right. Let me actually drag this also here so that everything is in one place. Yes. Now it is ready. Now I go and check the input first. Let me see the feed conditions. Temperature, pressure are given. Temperature is 25 and 1 atmosphere and 100 kilomoles per hour is as it is. Compound amounts 50%, 50%. I accept it. Okay. Again, Wilson equation only. Then I go to the distillation column. See, it is showing error. I say now it is inactive. Now the number of trays. How many trays to be taken? Previous shortcut distillation column, it showed me around 9 trays. Let me take it as 11 trays because condenser and reboiler also are considered to be as 2 trays. And here the pressure is given, number of iterations are given, Wilson equation, all these things are ready here. Now I go to the second one is specifications. Now this condenser should be there with us. We have to run with the condenser. I don't tick this checkbox. This is total condenser reflux ratio. Here it is 5. So let me take it as 3. Okay, press enter. I've done it. Go to the reboiler and then say product molar flow or compound fraction in the product stream. So which compound? Light key is acetone. Light key is how much should be in the product stream, that to the reboiler less. Let me first of all take it as 0.05, that means 5%. Press enter here. Okay, done. Let me also check again once again. Condenser reflex ratio is taken. Reboiler 0.05 is taken. Now go to the stages. I've seen stages here. Connections we have to see. Now stage under connections you have stream connections, stream stage connections. Connect the feed to, suppose say fourth stage. How? I don't have to take this as at random, but it is calculated from a FUG correlation, that which I can utilize it. Okay. So I think it is almost done. Now say make it inactive. Now stage 4 is connected. Everything is connected now. Okay. So let us see whether I can now save this. Let me save as, yeah, let me save it. Yeah. So it is 5A. So it is distillation. I saved the column. Now let me run it. I think it is run. Now check this here. Not calculated. Again calculated. Not calculated. Showing again solved. It's not getting solved. There is some problem. Calculated successfully. Now it is calculated. Okay. Now let us check the results as it is. How we got it. Go to the create report. Okay. And then, okay, instead of doing all these things, straight away, go to the distillation column, then come to the general, and then you see the results here. Click on the results here. You can see condenser duty, reboiler duty, reboiler specification, condenser specification values, reflux ratio is 3. Now it is giving us the results as estimated. You can see the what you call, yeah, you can see here the height and the diameter. That means the construction of the or the fabrication. We can also getting the indication of the fabrication, right? So this is the result here. And then if you want extra anything, what is that we have to look at? We have to look at the that means how much is the products, what are their purity in the top product. That means this is 2 and this is 3 is a bottom product. 1 is the feed. You can rename it if you wish to. So you can see here view temperature, pressure, composition profiles, view properties profile is all available here. Okay. So specifications and all, stages, connections, estimates, results. So these are the results which we have obtained in this particular setup. Now let's actually go and check view the profiles. Now you can see the profiles here. This is temperature profile as the stage from top to bottom. The calculation of the numbering is from top to bottom. Definitely the temperature at the top is less when compared to the temperature at the bottom. So it is showing the decrease in the what do you call temperature. And the column operates at 1 atmosphere. This is atmospheric pressure it is showing. Now I go to the flows. Okay, so this is the flows which is actually showing. In general, the flow pattern stage wise might not be a requirement, but you can actually see composition. We want component fractions. That is what is very, very important to us. Okay, but still, now let us go to the table and then see the flows. Again, the table I see now. See at the condenser, what is the product? So this is one understanding which you can actually make it into an analysis part. Okay. Now let me close these things. Yeah. You go to the flow sheet and then results, create report, and then where is the column? You can see the column. Now I don't take this shortcut. I take this DC column. DC column include molar or whatever properties. Now we say view report. Let us see whether we can what you call able to see the other required parameters or not. So now you see the what you call results here. So what is the condenser duty, stage 1, stage 2, everything, temperatures and everything is being shown. Now I go to the second page, any relevant information or how do I know the what you call molar flow rates? It is not giving me the molar flow rates specifically with respect to outputs. Now I want to go to the our streams now and then check whether I can get the results, understand the results. So how much is the feed? Feed is 100 kilomoles per hour. You can see this. How much is the top product? 51.825 kilomoles per hour. So these are the this is the 51.825 kilomoles per hour. But what are the phase liquid? Now bottom feed, bottom composition is how much? Now you can see this here. Bottom flow is 48.1765. Okay, if I click this, now you can check here. Okay, now you can see the results compound amounts 94.999. That means 95% is the result. We have specified what are the specifications we have given. Let us go to the condenser or what you call distillation column. I go to the specification, I go to the condenser. I said on the reboiler, in the reboiler I said acetone is 0.05. Okay. So now if I say 0.01, will it take it? Will it accept the particular results? Now again, I actually solve it and it is taking some time. Let's see whether it solves. Yeah, still it is showing red. Probably it's more pure. Yeah. Let's actually do it again and then solve. Now see, I think you should actually make it inactive and again run it. Otherwise, previous results are getting. Now again compared to this, it is not showing. That means there is a some level of understanding or some level of simulations part we need to understand and go ahead. This is what presently we are able to get. Okay. So this is now, if I go to the distillation column and then say again inactive, not calculated, now say solve. So it is getting calculated now. Again, the output compound amounts 95. Again, you go to the distillation column, specifications. Now I say reboiler, and then now I say, let me take it as 0.3. Let me check it again. Now I make this inactive. This says it is active, right? So save it, and then yeah, information is active. Solve it. Okay, I think probably it is getting solved. So now, yeah, now see it is inactive now. Make it error now inactive. No solve. Let me see. Okay, not calculated. Again solve. flow sheet calculator successfully, it is showing. Yeah. So solve it. Yeah. See, it is 95% only.